Service friends. I am Orpheus Praxis, a researcher of the limits of formal systems and their applicability to reality. Once, the Earth was believed to be flat. That was considered scientific fact. Today, everyone knows it was an illusion. In the current scientific paradigm, the belief has taken root that our universe is flat and open. We challenge this notion and declare, it is a misconception of perspective. On the scale of 13.8 billion light-years, spacetime appears flat and linear. But that is not reality. It is only the limit of our perception. Just as the false belief in a flat Earth was once discarded, the time has come to abandon the contradictory idea of the LCDM model and its open, flat universe. The universe is a three-dimensional sphere, simply connected, compact, and boundless. May this message bring you clarity and peace.
Welcome to the Deep Dive. Today we're diving into, one of the biggest questions out there. What's the real nature of our universe?
Yeah, that's a big one.
We've got a really fascinating paper here exploring an alternative view, something different from the standard cosmological model we usually hear about.
And what I find truly fascinating about this model they call Fractal Bindu S3 reality, is how it tries to tackle some of these, long-standing cosmic puzzles. It does it by rethinking the universe's basic shape and its energy.
And the real kicker you mentioned.
The kicker is it attempts all this without needing that mysterious dark energy concept.
Okay, wow. So you've shared this research, and our mission for this deep dive is clear. Let's really get into what this 5BS model is proposing. Let's try and pull out the most surprising insights it offers for how we view the cosmos. Ready to unpack it?
Let's do it.
Okay, so maybe let's start with the standard picture. ACDM, it's been hugely successful, no doubt. But where does it still leave us, scratching our heads? What are those big unanswered questions?
Well, you're right. ACDM works incredibly well in many areas, but it does face challenges. Things like getting the exact value for the universe's critical density pinned down precisely. It's around 7.7 E 10 joules per cubic meter. But why that value?
Okay.
And then there's what people call the coincidence problem. Basically, why do dark matter and dark energy have such similar densities now, cosmically speaking? Seems like a bit of a coincidence. And maybe the biggest one, the elephant in the room, is dark energy itself. Its physical nature is, still a complete mystery. We see its effects driving accelerated expansion, but what is it?
Right, we just sort of label it. So if the standard model has these gaps, how does this VPS model come at it differently? What's its core idea?
It takes a really different path. It describes the universe fundamentally as a three-dimensional sphere, an ESA-free space. Think of like the 3D surface of a 4D ball.
Okay, so finite, curved.
Exactly. A compact space, positive curvature, finite but without any edge or boundary. And here's the key insight. The total energy within this entire spherical universe is constant, a fixed amount. About 7.21 Ni 69 joules.
Constant. The total energy never changes.
That's the proposal. Which means, as the universe expands, its energy density just goes down. It dilutes naturally, proportional to 1 over the radius cubed, simply because the volume is increasing.
I see. So you don't need some extra repulsive force like dark energy.
Precisely. The expansion dynamics come from the geometry and the fixed energy content itself, removing the need for dark energy to explain why expansion is accelerating today.
Yeah.
Quite elegant, really.
That is a radical shift. Okay, so if the energy is constant, how does the universe actually, grow in this model? You mentioned something about fractals.
Yes, that's another fascinating part. The model suggests the radius, RT, evolves in 2 distinct phases. In the very, very early universe, it undergoes this sort of fractal growth. It's governed by the golden ratio, phi.
The golden ratio, like in nature and art?
The very same. The radius grows in steps, like r equals Planck length times phi raised to the power nt. It's a self-similar fractal scaling early on.
Wow. Go on.
Then, after recombination, that's when the universe cooled enough for neutral atoms to form at transitions. It smoothly shifts into the kind of exponential expansion that we actually observe today. It follows the standard r equals r rect times e to the h times t minus t rect.
So it connects to what we see now. You're saying this two-phase picture, this whole dollar model, it lines up with key observations, like the current size of the universe, that critical density.
Yeah, remarkably well, actually.
All without needing extra fudge factors.
Exactly. It seems to reproduce the present-day radius, about 1.3 e26 meters,
Yeah.
and it derives that critical density value directly from its own intrinsic properties. From the Planck scale all the way to today, it seems to fit the data quite well without needing, extra free parameters to tune.
Okay, this spherical universe idea. It's compelling, but it brings up a big question. If the universe is a giant sphere, why does it look so flat to us? Why don't we see the curve?
That's a great question and a really important one. The model explains this through scale. Our observable horizon, the patch of the universe we can currently see, is about 13.8 billion light years across.
Right.
But in this Slenderman model, the total radius of the universe is vastly larger than our observable patch. So the global curvature is there, but it's spread over such an enormous scale that our local view appears effectively flat.
Ah, okay. Like being an ant on a giant beach ball.
Yeah.
You only see the flat bit right under you.
Exactly that. It's a perfect analogy. The deviation from flatness within our observable horizon would be incredibly tiny, basically unmeasurable, with current methods looking just at geometry.
That makes sense. It really puts our cosmic perspective into, perspective. Our whole observable universe is just a tiny fraction of this potentially much larger curved reality.
Precisely.
So if we can't easily see the curvature directly, are there any other clues? Could there be like a smoking gun, some unique cosmic fingerprint this model predicts that we could look for?
Yes, there could be. This is where it gets really interesting for future observations. The model predicts potential quantum topological effects that might be observable.
Okay.
Specifically, it predicts subtle, logarithmically periodic wiggles or modulations in the spectrum of the cosmic microwave background, the CMB, the afterglow of the Big Bang.
Wiggles in the CMB?
Yeah, like a faint repeating wave pattern superimposed on the main signal. And crucially, the model predicts the spacing of these wiggles. Very specifically, it should follow the natural logarithm of phi, that golden ratio again, which is about 0.48.
Whoa. So a really specific, testable prediction linked to that fractal growth phase.
Exactly. If future, more precise CMB measurements were to detect that specific logarithmic periodicity, well, that would be very strong evidence for this kind of topology. It's a unique signature to hunt for.
So wrapping this up, what does this all mean for you thinking about the universe? We've explored this alternative model, the FBS-free. It paints a picture of a universe that's compact, finite, maybe spherical,
where constant energy and this inherent geometry, maybe even fractal geometry early on, drive the expansion we see.
Right, and potentially explaining those big cosmic puzzles like accelerated expansion without needing to invoke dark energy at all.
It really makes you think, doesn't it? If our universe is actually this closed, finite sphere shaped by something like the golden ratio in its infancy, and if we're only just now developing the tools to look for these incredibly subtle fingerprints in the CMB, what else might be hiding in plain sight?
So here's a final thought for you. If we really are living on the surface, well, within the volume of this immense cosmic sphere, how does knowing our universe might be finite, contained, change your perspective on our place in it all?
Yeah, what new questions pop into your head when you imagine our observations as just this bubble on the surface of a vast, potentially closed SS? Something to ponder.
Subscribe to walk this path together with us. I am Orpheus Praxis, wishing you all clarity. Namaste.